Hey guys, welcome back. Welcome to page 3, rock and roll. Make sure that you guys spend a little time looking at this, and if you need to email me as you're working through, of course, email me right away, and I might be able to get back to you tonight. So let's go ahead and just solve this. We're going to graph it. That's what it's asking us to do. And then, so to graph it, let's put it in slope-intercept form, because that's the way I like to graph. It's kind of fun. So we're going to minus 2x from both sides, so we get in slope-intercept form. And we do that so that we can just look at it. We can see that right there, that negative 1's the y-intercept. So the y-intercept being -1, so we're going to put a dot there. And then our slope being -2/1. So from that point, we're going to go, it's -2, so we either go up or down based on the negative. So we're going to go down 2, and I like to always go to the right. So, and then you guys use straight edge. I don't like, I got to erase a bunch of times until I get a nice, perfectly straight line just like that one. Perfect. Oh, that went away. Anyways, so perfect straight line through the 2 points. Perfect. Now let's go to the next one. I'm going to solve for y first. So I'm going to add 3x to both sides. I'm going to solve it for y again. Why am I going to do that? Well, so that I can read the slope and the y-intercept at the same time. Divide by -1, divide by -1. We get y equals -3x minus 2. So from here, we're going to start at -2 being the y-intercept. Then it's -3, so we're going to go down 3, right 1 again. And notice that the graph is going down from left to right. The line is going down from left to right because the slope is actually, in fact, negative. Okay, let's match the graph with the thing. So first off, there is only one line on this graph that has a negative slope. So if I go over here and look at the ones with negative slope, it's 21. So 21, okay, so this one right here, that's going to be graph 21, number 21, okay? Or y equals -1/2 x plus 1, because it's going down from left to right. So that's check. Now I'm going to look at these two equations. Slope's the same, they're parallel, so the slopes are the same, but notice the y-intercept changes. So on the picture, I'm going to look for where the y-intercept is. So on this one right here, that line right there, that y-intercept, here's the origin, 0, 0, go up 1, so it's a positive 1. So this one right there is actually 22, or y equals 1/2 x plus 1. And then this last one, the one above it, that parallel line above it, has got to be 20. And just to verify that that y-intercept is positive 2 on the graph, and we look over here and the y-intercept is positive 2. Fantastic. Okay, let's go ahead and crank out the next work here. Let's go to 23. So let's read the problem. Refer to the triangle on the right. State whether each statement is true or false. If the statement is false, explain why. Okay. So it's a right triangle. Okay. Well, in the picture, it's a right triangle, but we're actually asked if these are the 3 sides, is it a right triangle? So if you notice, z is the hypotenuse. So z right here, when we use the Pythagorean theorem to verify if it is a hypotenuse, or if it's actually a hypotenuse, or verify if it's actually a right triangle. So we're going to put the largest one on the other side of the equal sign, okay? Especially if the picture, if that's lowercase c, it's going to be on the right-hand side. So we ask ourselves, does that equal? Is that accurate? If that is accurate, then we can conclude that, yeah, it's a right triangle because the Pythagorean theorem holds true. So that is true. On the left, you get 25, and that's 25, so we're good to go. And the next one, we check to see, does, okay, if z right here in the picture, as it's labeled, is there, so we're gonna check it. Oh. All right, guys, let's take a look at this one. By the way, that since we're just doing kind of a true-false thing, and there is a right angle on there, z, we're saying that this triangle is a right triangle automatically. So that's like given in the actual setup of the problem. And then we're sitting here. So is this true if these 3 measurements are the same? You could actually stop here on number b. So if z is 9, x is 15, and y is 17. You can stop there because we know. Remember we talked about how the hypotenuse of the one across from the right angle has to be the largest. So you could actually stop there. because it's not the largest side. But what you could do, just for completeness, is you could set it up, throw it in the Pythagorean theorem, and see if it's equal, but it's not, so we'll just leave it as such. Okay, we actually need to check these out, because these next ones out, because z is 2. Okay, z is listed as being 2, so then we're going to turn around and check these out. So let's see if 1 squared plus 1 squared, is that equal to 2 squared? Well, we get that's 1 plus 1, so it's 2. Is that equal to 4? No, so it's false. It's false. 2. Now let's go to the next one. Okay, is 1 squared plus 2 squared equal to 3 squared? Okay, we're okay to even try that. We're okay to try that because z is the longest side. 3 is larger than 2 and 1, and then it's also in the picture across from the right angle, so it's the hypotenuse, so it has to be the longest side. Anyways, so 1 squared is 1, 2 squared is 4. Is that equal to 9? Well, that's no, so the answer is false. Okay, let's take a look at the next one here. True or false? So looking at this picture, Pythagorean theorem we want to talk about is m squared, that's a leg, plus p squared, which is another leg, equal to n squared. Absolutely, that is like straight from the Pythagorean theorem. If you notice that since n is the hypotenuse on the triangle, it's on the other side of the equal sign when we deal with the Pythagorean theorem. So we want to turn around. That's straight Pythagorean theorem using that triangle to explain. Okay, and B, is that true? Let's see, is that true? So n squared, okay, that's on the other side of the equal sign. That's got to be the hypotenuse, then we're good. M squared and p squared, yeah, that's true. That's actually just, you actually use the symmetric property of equality for A, which turns it into B. Anyway, so next, C is true. Is that true? M squared is by itself on one side of the equal sign. No, it's not true. This one's going to be false because M is not the hypotenuse in the picture. And let's see if D is true. Well, okay, this is a little bit weird. It's kind of like this is kind of like B, right? But it's like B if we solve it for N, isn't it? So if we square root both sides, boom, boom, we actually get right there. Well, that means that's true if M, P, and N are the measures of the right triangle. Peace. Okay, let me know if you guys have any questions, of course, and we'll go on to the next page on the next video. Hope you guys have a great time, and thanks for being great and working hard.